Hey everyone, welcome. This is the fourth set of videos. I'm going to create the fourth and last set where I'm going to look at diving into an actual application of data science on the RTEM Hackathon data set. If we go back to the website, you'll all notice, I just want to cover this again just as a refresher. The website itself has information about NYSERDA, who's hosting the competition, NYSERDA and Onboard, and the ASHRAE New York chapter. Data submission, all the ways you do it, the timeline, the cash awards, of course, which is, yeah, that's the good thing too, right? But I want to take a look down here at judging criteria. Let's come back to this because I've shown you how to, access the API and download the point list and download the time series data. Let's really look at, okay, what do we do? What do we use all this data for? And what's the whole point of this hackathon? And long story short, the hackathon is very broad. It's a very broad scope in a sense. In fact, they don't really give you a specific scope that you're supposed to do. You might, if you remember the great energy predictor competition from the Kaggle platform, that was a very specific scope. It was exactly to create a prediction model to predict hourly data for this time period, and you submit your submission, and there's a very objective criteria for the most accurate solution. This hackathon is much different. It's very wide open. You're only limited basically by your imagination and the time and resources that you have to do the competition. You are going to be putting together a solution, and this solution is going to be scored based on objective or subjective analysis by judges of how your use case, the novelty of your use case, first of all, that's 10 points, how your submission is instrumental in using the whole data set, what it's, and it identifies all these different principal actors, activities, interactions, minimum data schema, etc. So really, outlining what your application is. And we'll talk about in this series of videos kind of, what are some of the ideas that you could execute in a sense. What are the directions you can go in? There's actually a ton of directions actually. The second criteria is market adoption and impact. So how easy is this solution to actually, how realistic is it that it would scale across the building stock and make a big impact on the built environment context? So this is really important. This is really like, we can all come up with really fancy solutions, but are they, ready to be adopted, and how much impact could they actually have? That's something that this looks at. Decarbonization through electrification, that's another 10 points. So looking at ways that your solution can help promote electrification through lowering the carbon impact of a certain building, or analyzing the contextual understanding of how to convert possibly certain buildings into more electrified buildings. Ease of implementation. So if this is all about adoption, so this is kind of related, I think, to a little bit to number two. So number two seems to be more about the impact that your solution would have. Ease of implementation is how easy, that's how easy your solution would be. And then last but not least, use of open data sources. So you can utilize the RTEM data set. You can use other publicly available data sets and merge those data. So that's really where we get a lot of synergies with data sets. So you might find weather data or social media data or other open data sets or what have you that you could merge into this solution. So this is my I'm not on the judging panel. I don't really know what's inside the heads of all the judges or the planners exactly. This is kind of my impression. But I mean, I just wanted to, very much focus on the fact that this is kind of a very open-ended hackathon, which is a blessing and a curse, right? A blessing in a sense that you can really use your imagination, take this in a certain direction. A curse in a sense that it's like, well, what do I do? How do I approach this? What do we tackle? So in this set of videos, I want to talk a little bit about that and show kind of an example of, like if I were to be in this competition, which I won't be, how would I approach this in a sense? So if we come over here to the Kaggle data page where we've been looking at part 1, part 2, part 3, part 4, Part one, of course, API, metadata exploration or point data exploration, time series data analysis, and then finally we're here at this last part, example starting point for RTEM analysis. This is a notebook called Use Cases. Of course, you can copy and edit this into your Kaggle account and modify it and that kind of thing. Bianca Pinchetti is the main author of these notebooks, and she's my data science collaborator partner that has developed this, and I'm just giving you an overview of these notebooks. So let's get started on this notebook. I have this in my own account here, you can see. Of course, we get started as usual by installing the onboard client package, like loading all these packages, including Python, Pandas, onboard client, Matplotlib, and Seaborn, which we've used before. Of course, the API key, you can copy and paste your API key there, or you can use the Kaggle secrets, which I use. You can see you can't see my code, my API key, but it's there and it's being used. And you initiate the client with your key. And then, let's dive into how I would approach this. So, my background, part of my background has been in a field called fault detection and diagnostics. Also known as anomaly detection, or finding anomalous behavior, weird behavior, motifs and discords and things like that. So the automation of finding interesting behavior in this type of data is something I'm really interested in. So this is how I would approach it to begin with. I would start exploring, right, which we've done in a lot of the other videos, focus on time series analysis and metadata. Like, what do we have in this data set? What are the points? What are the equipment types? And then looking at the time series data, where is the interesting behavior? And then what are the interesting ways that we could capture that behavior in a more automated way? Because a human can't look at all the data and analyze it and with this many data points, 46,000 data points. So this is how I would approach it. And Bianca helped me develop this notebook to kind of show an example on this. So first thing we'll do is load the data that we've extracted. If you remember the last set of videos from fan coil units, in this time we loaded the discharge air temperature. So this is kind of the temperature after the coil and the fan of a fan coil unit, and also the command for the fan coil unit. So the signal being sent by the BMS to whether the fan coil unit should turn on or off. So these two files have been downloaded in previous work and saved as a CSV file. So I'm not querying the API at this point. I can load those files. I can take a look at, if we load, for example, this discharge air temperature file that we just loaded, and look at the columns, there's actually 111 discharge air temperature for fan coil units from this. You'll notice that the column heading is it's three numbers put together with underscores. These are the building ID, equipment ID, point ID. So kind of a hierarchy of points. And we created, Bianca created that sort of hierarchy as a way to store the data as a flat file very quickly, and then we can reference it again and kind of parse that column heading. So it's just a way that we sort of played with the data and a way to kind of flatten it and store it. You can analyze the data in your own way. You can query the API and as many times as you want to kind of get these hierarchies, but this is just the way we looked at it. So first thing we'll do is, of course, resample. We can use 1H, or you can just use H for hourly resampling. And then let's take a look at the data real quick. So let's first make a heat map of the data. Here we have it. So you can see the discharge air temperature for these points. You can see lots of blue. You can see the color chart here. This is in Fahrenheit, anywhere between 40 to 160 degrees Fahrenheit. And throughout all the operation here, you can see that there's a lot of very consistent operation. A lot of these fan coil units' discharge air temperature is modulating somewhere between 55 and, let's say, 70 or 80 degrees Fahrenheit. Right, but then you have some interesting behavior here that's slightly different. Seems like a few of the fan coil units are running with a discharge air temperature much, much higher. So why is that? What's going on there? Why are these different? Why is that weird? Those kind of things. Let's take a look at that in the next video.